Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be talking about how to find the H plus concentration and the pH for mixtures of acids. And so there are two categories or two situations you want to think about as far as a mixture of acids. The first one is strong acid and a weak acid together, mixed together. And the second one is where you have two weak acids together. So let's talk about those in turn. So first of all, we're going to talk about strong acid and weak acid mixed together. And so here's an example. So if I have a 0.10 molar solution of HCl and I mix that with a 0.10 molar concentration of HCH2O or CHO2. So this is my weak acid, this is my strong acid. So here, let's lay out the possibilities. So when you're thinking about calculating the concentration of the H plus concentration in your solution, remember when we're just dealing with the one acid, we also had the auto ionization of water to worry about, right? But we said basically we can ignore that as long as we're dealing either with a strong acid or if we're dealing with a weak acid that has a relatively high Ka value compared to that of the Kw for water, right? So here, if we have a mixture of acids, again, um, assuming that we have uh, the same concentrations here, the first reaction that we're seeing here is the reaction of the strong acid. So the Ka value is very strong. It's very much high, a very large Ka value. So we just say strong there. And so here's the equation for the breakdown of or the ionization of HCl. Since it is a strong acid, it's going to 100% or very close to 100% um, uh, ionize into H plus and Cl minus. And then comparatively, we see that the weak acid, HCHO2, is going to react with water. It's going to be in equilibrium. It's only going to partially ionize. And so you can see that the Ka value is 1.8 times 10 to the negative 4. And so you can see here also with the Kw, the auto ionization of water, that has a Kw of 1.0 times 10 to the negative 14. So here you can see that because of the strong acid is actually going to suppress the ionization of the other acids here, the weak acid and the auto ionization of water. Well, why is that? So if we go back to Le Chatelier's principle, remember that the strong acid is dissociating completely, so it's dumping a whole bunch of H plus ions in solution. So what is that going to do with the equilibrium here, right? So we're taking an acid, we're basically taking H plus and we're dumping it into our solution. Well, according to Le Chatelier's principle, if we're increasing the amount of product here, then this is the equilibrium for these two is going to shift towards that way. So even less of the acid is going to ionize. And so this is going to be less of a concern than we would normally have. So under normal conditions, even under normal conditions, if we were to calculate the amount of H plus from this acid, it would be basically equal to the Ka value here. So the H plus concentration from this weak acid would be 1.8 times 10 to the negative 4, which is much, much smaller than the amount of H plus concentration you get from the strong acid alone. So we can ignore the H plus coming from the weak acid. So and then also in addition to that, because the Kw here for the auto ionization of water is even smaller than the Ka value of the weak acid, we can even ignore that as well. So when you have a strong acid and a weak acid mixed together, you pretty much ignore the other two and just calculate the H plus concentration due to the strong acid. So that's how you deal with the mixture of a strong acid and a weak acid. So what about two weak acids? So here's an example of two weak acids. So let's say we have a 0.300 molar HF, which is a weak acid, and we're going to mix in with that a 0.100 molar concentration of HClO, which is also a weak acid. And so once again, we have three sources of H plus that we need to worry about. So we have the H plus coming from our weak acid, hydrofluoric acid. So we get that H plus there. And that has a Ka value of 6.8 times 10 to the negative 4. And then we have HClO also here. So that is going to also ionize, and we're going to get H plus concentration. And so the Ka value there is 2.9 times 10 to the negative 8. And once again, we have our autoionization of water. Again, that Kw is 1.0 times 10 to the negative 14. Now, in this situation, um, if we have Ka values for our two weak acids, if those Ka values are different enough, then we can ignore one of the weak acids. So as long as the difference between the weak acid, the Ka values, the weak acids is significantly different. And what we mean by significantly different is by more than a factor of several hundred. Then we can ignore the other acid and focus on the stronger of the weak acids. As long as, of course, the the concentrations of those acids are relatively close together, if they're the same, or if the stronger acid has a higher concentration. So here, if we're doing this one, hold on a second. Sorry about that. So since we have HF here, which is a weak acid, it's the stronger acid of the two, and we have more of it. So we don't have to worry about the difference in the concentration of these influencing. And you'll notice that the Ka values for the two acids they differ by well more than several hundred. So the difference between -4 and -8 is about a difference of like 10,000. So this HF is going to be much stronger of a much stronger of an acid as a weak acid than HClO. And so again, the Kw value can be ignored as well. So we don't need to worry about the autoionization of water. And again, for the exact same reasons, because if we take in consideration Le Chatelier's principle, that principle, again, means that this acid is going to suppress the other two equilibriums here. So since we're producing a lot more from our HF, that production of H plus is going to cause these to be suppressed. And so even less H plus is going to come from these two. So then even in this situation, we can ignore the other two and just focus on the H plus concentration formed from the weak acid. And so we can do our ice table and then figure out what the H plus concentration is from our weak acid and then go from there. So I hope this was helpful. In a few other videos, I go over examples of mixed acids and how to calculate those, so you can check out those videos. If you like this video, please hit that like button. If you like my channel, please subscribe to my channel. Hit the notification bell so you can be notified by other videos I put out. Put a comment in the comment section. Let me know what you think, and ask me any questions. Thanks for joining me, and have a great day.